Hi, this is Sunshine from Villanova University. I'm going to introduce a wireless communication system prototype we built over a wireless testbed. NOMA has attracted a large amount of research attention. It can transmit signal use the same resources such as time, frequency, code, or space domain, while sharing the transmit power. This mainly requires two main procedures: superposition coding and successive interference cancellation. We're going to implement the two main procedures using a hardware board, USRP 2974, serving as an analog and RF front end. Besides, the LabVIEW NXG 4.0 serves as the host for prototyping. The NI USRP 2974 is a transceiver with two transmitters and two receivers. USRP 2974 allows internal loop experiment. The network simulates a base station transmits a superimposed signal to two different users, each with one antenna. The experiment is built in an indoor room. One of the users is 1 meter away from the transmitter. We call it near user. The far user is 4 meters away from the transmitter. To generate the superimposed signal, we have this formula. For example, if we have a 16 QAM and a BPSK signal added together, from the constellation, it will become a 64 QAM. For the SIC, when a far user receives the signal, this user can demodulate and decode the signal directly. For the near user, this user has the ability to decode both of the user's message. Thus, the user can first decode the far user's message, and then subtract it from the received signal, and then decode its own message. We program the code in the diagram. The code includes the transmitter and receiver blocks. In the receiver block, we do equalization and then decode for each user. In the front panel, we can set the parameters and the configuration. In the TX configuration, we enable one antenna for the transmitter, and it works in 3 GHz. The sampling rate is 10 million, with number of samples set as this. The RX configuration are set here. In the NOMA panel, we can set the modulation tab for each user, modify the samples per thimble and the NOMA width. It also shows the power spectrum, power level, received IQ data, and the transmit waveform. Also the constellation. Now what is showing is the P2P MIMO of the near user. You can see now it is 16 QAM. To reach the capacity, we start the SIC button and set the NOMA width for each user. We modify the samples per thimble and the modulation tab to get an acceptable bit error rate lower than 0.1%. We can see from the figure that NOMA can do better than OMA. Each one is obtained based on the configuration from the table. Thank you for watching.